discuss the limit theorem. So limit theorem, its existence and evaluation. Now dy by dx, so generally it is used in differentiation. We are still to come across, we will discuss later on. So dy by dx, so it is the limit of difference quotient, delta y by delta x, as delta x tends to 0. So delta y by delta x means what is the change in y is a dependent variable due to very small change in the independent variable, that means the variations. So when delta x tends to 0, very small, almost 0, then what will be the change in y? So let u is this quotient delta y by delta x, and v is equal to delta x, that is the variation. Then dy by dx, limit delta x tends to 0 is equal to limit u when v tends to 0. When v is almost 0, then it will be limit of u. To understand derivative, concept of limit is very important. So when we will study or discuss derivation, then every time we will have to do this limit. Limit. So for single functions, now coming to the theorems, for single functions, suppose u is the function of v, and the form is u is equal to ab plus b. That means it is a straight line when b is the intercept and a is the constant. It is the rate of change of b. B is the constant. So ab plus b. So limit u when b is equal to n, it is an plus b. A, b are constants. Example, u is equal to 7v plus 5. So limit u when v is equal to 2, that is v tends to be 2, then limit u is equal to 7 into 2 plus 5 is equal to 19. So limit u when v tends to be 0, so it is 0 plus 5 is equal to 5. So when p tends to be 2, it is 19, but when p tends to be 0, very small, then limit u is equal to 5. 5 is the limit. Then theorem B. Now u is equal to, u is the function of v is equal to b. Suppose it's a constant. Then limit u, v tends to n, limit of a constant function is the constant itself. So it is the constant itself. Then theorem C, u is equal to v, limit of u, so v tends to be n. So limit of u is equal to n. If u is equal to b to the power k, then limit u, so p tends to be n, then it will be n to the power k. So if p tends to be n, then u is equal to, limit u is equal to n to the power k. Instead of p to the power k, it will be n to the power k. So n is a particular number. Now example, u is equal to v cube, e to the power 3 minus v cube. So limit u, so when p tends to be 2, then u is equal to 2 to the power 3. That means it is 8. 2 into 2, it is 8. Then second theorem, theorems involving two functions. Suppose independent variable is same, but dependent variables are different. So in terms of say to say the domains are same, but the dependent variable, they are different. So limit q1 is equal to L1 when V tends to be n, and limit q2 is equal to L2 when V tends to be n. Okay. Then D, limit q1 plus minus q2. So where the q1, it may be q1 plus q2, or it may be q1 minus q2 sometimes. So it is L1 plus minus L2. So limit of u, limit of a sum or difference, sum or difference of two functions is the sum or difference of their respective limit. So respective limit is L1 and L2. For Q1 it is L1, for Q2 it is L2. So it is the sum of their respective limits. So here E tends to be n, and limit 2q1 is equal to limit L1 plus L2. P tends to be n, so it is 2L1. Then product limit theorem. So limit q1 into q2. Earlier we have got q1 plus minus q2, but here it is product limit q1 into q2 when p tends to be n. So it is L1 into L2. The inference is limit of a product of two functions is the product of their limits. So limit of the product of two functions q1 and q2, and it is equal to the limit of the respective functions. So limit of a product of two functions is the product of their limits. So this is all about limit theorems. Because as I said earlier, that limit in mathematics, limit is a long chapter. So we are not going to discuss as pure mathematicians, as I said earlier, that whatever is most applicable in economics, we will deal with that. Okay? So if somebody is very much interested to go into details of maths, they can go to the books also. Okay. So this is all about the limit theorems. So thank you, and once again we'll meet.